So today, we're going to learn our first form of a linear function. There are going to be three. Today, we're going to start with the slope-intercept form of the line. And it literally tells you what's in there. You're going to find the slope, and in this case, the y-intercept. And this little picture here will kind of show you. So if you ask anybody for the form of an equation of a line who's already gone through algebra, they often will just go y equals mx plus b. And so that's what we're going to be talking about today. We're going to write the equation of a line in slope-intercept form, and we're going to use this form to graph a line. And today we're going to be a little bit sad, maybe a little bit happy, because the fave 5 are going to go away. So before we get to that, I want you to look at this graph, and you can notice that the rate of change, or the slope, changes. So if we look between these 2 points, we have a rise of 1 and a run of 2. The slope is 1 over 2. But between the next 2 points, it's 2 over 2, or 1. Notice how the slope changes. And even up here, it grows more rapidly, which is 4 over 2, or 2. So between the points, the slope keeps getting bigger, and we notice that we have a curve, not a line. So it's not a linear function. It's because the rate of change, oh, by the way, the slope, changes so that it doesn't stay linear. So a graph, obviously, of a linear function is a straight line. But how could we tell that it's linear without graphing it? Well, first of all, we've already talked about that in our last unit. When we have a function rule, we can tell when it's part of the linear family. But what if we have a table of points? So I just wanted to show you these 2 examples. So if I was to pull some points off this graph, like 0, 8, and 5, 5, and 10, 2, and I even gave you another one here that's off of the graph, you'll notice that as I pick any 2 points, I will always get the slope that is the same. So 8 minus 5 is 3, and 0 minus 5 is negative 5, and so forth, all the way down the table. So the slope is the same between these 2 points, is the same between these 2 points, is the same between these 2 points. If the slope, as you go from point to point, remains the same, it has to be linear. Now over here, you can see, as I was just talking, the slope changes. Now, when you're checking for linear, you cannot just check the top 2 and the bottom 2. They have to connect. You have to make sure that they connect, because instead of having a line, you could have a different slope in between here, and it would look more like a lightning bolt. So you check between connecting points, and if the slope stays the same, then it would be linear. Now, what I'd like you to do today is we're going to discover this y equals mx plus b thing. And we're going to do it using the Desmos calculator. So I want you to open up your calculator, and I want you to graph all 3 of these kind of on the same slide. So I'm going to go out to Desmos and find that calculator. Here it is. And right here, you're going to type the first equation. When you're set typing that one, you're going to then type the second one. Just click down and type the third one, so that all 3 of them will show up over here. Once you have those, you're going to go back to the movie, and I'm going to ask you a question about it. Okay, so go out to Desmos.com, and please graph y equals 1/2 x, y equals x, and y equals 5x. The video is going to stop for you to have a chance to do that, and when you come back, I'm going to ask you, how does the coefficient of x, the number in front of the x, affect the graph of an equation? So hopefully you have that answer, and we're going to look at the picture in a second together and then talk about that. And now I want you to do a second thing. So again, answer that question, how does the coefficient of x affect the graph of an equation? And now you're going to go back out to Desmos, and this time you're going to change your 3 to be y equals 2x, y equals 2x plus 3, and y equals 2x minus 4. This time we kept the coefficient the same, but we changed sort of the number after the coefficient. So where does each line cross the graph, cross the y-axis, that should say? And, try some other linear equations just to see if you can understand what does the number in front of the x do and what does the number after. All right, so let's just take a look. I have the pictures here. So that first three should have looked something like this. So what does the number in front do? So you're going to notice this is the 1/2. The red one was the y equals 1x and y equals 5x. And if you notice, let's just look at the blue one. You take 2 points, up 1, 2, 3, 4, 5 over 1. The slope of the blue line is 5. And oh, by the way, the slope of the red line, 1 over 1, is 1. And the slope of the green line, you go up 1 and run 2, is 1/2. Did you recognize that the slope is the coefficient in all of these equations? When you have y isolated in a linear function, the number in front of the x will be the slope. Now notice they do all have one thing in common, which is they're all going through the origin. Why are they all going through the origin? Now their slopes are all different, but what in this function rule is telling us that? Let's take a look at the next group. So in the next group, the 2 stayed the same in the front. And oh, by the way, if you look at all 3 of these lines, rise over run is 2 over 1, 2 over 1, 2 over 1. So that 2, again, represents the slope. But this time, notice the 3 lines are all parallel. Oh, by the way, they have the same steepness, the same slope, but they are hitting the y-axis at different points. So the black line at -4, the yellow line at +3, and I put the +0 in there because, see, he's going through the origin. So notice that when we solve a linear function for y and have the y isolated, the coefficient of x is the slope, and the constant that follows it, the caboose I like to call there, is the y-intercept. Y equals m, slope, x. Now the y-intercept has an interesting letter. It's called b. So the coordinate of the point where a line crosses the y-axis is called, the y-intercept. And the slope-intercept form of a line is y equals mx plus b. So the slope we already talked about is m, and for some reason, they called the y-intercept b. And I have never really been able to find out where the origin of the b is, why they chose b. So this is very, very helpful to do a lot of cool things. So that's where we're going to go now. So y equals mx plus b is the slope, m, intercept, y-intercept, b, form of a line. So first of all, you're going to notice these are kind of scattered around because when you come into class, I'm going to do a couple. We're going to do a reteach, make sure everybody's good. So the first thing I want you to do is just to look at these and tell me in each case, what is the slope and what is the y-intercept? So over here, did you say that the slope is 3 and the y-intercept would be -5? Always make sure to tell me which is which, like put the m and the b. Otherwise, I don't know if you know which is which, basically. Okay, come over to this one and try this one. Did you say that the slope is -2? And because this is missing, the b would be 0. Now, in the next 2 problems, I just want you to do the opposite. I'm giving you the slope and the y-intercept. You write the equation. Yes? I'm going to just tell you, often a mistake people make, obviously other than switching them by accident, is to not put the y equals. It's just to make it an expression. It's an equation, so there should be an input and an output for that function. And how about this one? A little bit interesting over here. So did you get the fact that it's going to be y equals 0x, and 0 times x makes the x disappear because 0 times anything is 0. And 0 plus 7 is 7. So this, with a slope of 0, is a horizontal line. It's the floor. There is no slope, so it's a flat horizontal line. So the equation of any horizontal line will always be y equals whatever the y-intercept is. So y equals 7 is a horizontal line through the y-intercept of 7. Every horizontal line is y equals a number. Did everybody hear that? Every horizontal line is y equals a number. I'm just going to give this to you right now because you might want to play a game at the end, and it will involve, what about vertical? Well, vertical lines are not functions. Think about that, right? But I'm just going to tell you that if a horizontal line is y equals a number, a vertical line will be x equals a number, and it will be the x-intercept, okay? So just if you play the game at the end, you'll need to know that, but we will talk more about that in a future section. This is where you're going to kind of maybe get a little upset with me because I'm going to graph this function, and we're not going to use the Fav5. So right now, if you want to have a little kind of just a moment of thanks and gratitude to the Fav5, you may do that, but we're going to say goodbye to them. Because when we have an equation in the slope-intercept form, we can graph this so incredibly easy. So you remember in our last video that as long as you have a point in the slope, you can graph a line. You have a start point, and you use the slope to move. So in this, hidden in this equation, we have both. The start point this time is our y-intercept. So go to your y-axis and find -1, and that will be a point on the line. Now, use your slope to move. So we are going to rise 3 and run 1, and there's a point. And then we're going to grab another point, and we're going to go to that point, and we're going to count and rise 3 and run 1. And then we come in with our rulers and put in our line with arrows on both ends. And voila, there is our line. And we never had to do any math. So the Fav5, thank you guys, but we don't need you anymore. Hey, Mrs. Ritter, why didn't you tell us this to start? Because you really wouldn't have understood where it came from. You just have, you're smarter than you were. And this is a new way to do it that's easy. Okay, so somebody out there should be saying, okay, that's great, but what if the equation is not in y equals mx plus b form? So you might remember back in Unit 2 that we did this section calling transforming formulas. And in that section, which didn't really happen great in our book, so we actually used a worksheet. It was 4-4 examples and mixed. Anyway, we had to solve for a different variable. And believe it or not, you actually did solve y equals mx plus b, like you solved it for different variables. Right now, if you look at this, we need the y by itself. You would be tempted right now to say that the slope is -2 and the y-intercept is 7, but it's not in the right form yet. Y has to be on his own little island, so this guy needs to move to the other side. Now I'm also going to give you permission right now that if you can do that without showing the step on both sides, I am going to let you do that. If you goof it up, keep writing the step. In other words, -7 and -7, right? And you should get this. But if you keep slapping that 7 over there and putting it +7, then write the step. But that no longer counts for points. We're out of Unit 2, and I am happy that if you can do some of this math in your head, I'm okay. But if you do it wrong, please go back to showing the steps for yourself. So now let's look down here. Wait a minute. So on this one, can you solve this for y? Think of transforming formulas back in Unit 2, and I'm going to ask you to try this one on your own. So the first thing you should have done was to add 2x to both sides. Is everybody okay with that? So this would go away, and the 2x comes to the other side. You might remember that I said, oh, leave the constant as the caboose, because in the future that will help you. That is why I said that back then, is to get this in y equals mx plus b form, okay? We're not done now. The opposite of multiplying by 3 is we're going to divide by 3. And can you please make sure to divide everybody, not just the 6. Divide this term, and this term, and this would be your y equals mx plus b equation. And now, there is your slope. there is your y-intercept, and you could do an easy graph by plotting the 2 on the y-axis and rising 2 and running 3. And you'll have more practice to do that graphing as well. Whoa, this one's a mess. Okay, so over here, could you please solve this one for y? Kind of 2 ways to do this one. You could divide by -4 first and kind of go about it that way. You can do the distributive property. I think I did it that way here just to show you. And then we would add the 12x, and then we would divide everybody by 8 and simplify. And you would have 12 over 8, which you can divide by 4. You have 3 over 2. So this is your y equals mx plus b. You could plot 2 on the y-axis, rise 3, run 2, rise 3, run 2, boom, instant line. So you might have to do a little bit of transforming to get your particular linear equation into slope-intercept form. So just so you know, we're going to go on and learn some other ways to write linear equations other than slope-intercept, and they all have their own use. So this one is what I call case 1, kind of a Woodruffism here. When you are given the slope and the y-intercept, it is really easy to write the equation of the line. You just put it in y equals mx plus b, and you're good to go. So pretty soon we're going to talk about real-world examples, and we're going to see how we can find the slope and the y-intercept in the example. If that's what the word problem has, it's very easy to write the equation. So right here, I've got 3 sets of things going on, and what I'm asking you is to write the equation of each one. So start with number 1. So did you see I was given the slope and I was given the y-intercept? So y equals mx plus b. Try this one. When the slope is 0, you're going to remember it's a horizontal line. It's the floor, and that 0x is going to leave. Remember I said every horizontal line is y equals a number, and in this case, it would be y equals the y-intercept. Every horizontal line will be y equals a number. Okay, last one. How about this one? Did you see that I gave you the y-intercept just in a different form? If you plot the point 0, -2, it's on the y-axis. So there is your y-intercept. So y equals mx plus b. Okay, so let's go backwards for the last thing before I show you there's a game out online that you can play with the zogs. More on that to come. But what I want you to do here is go backwards, and can you look at the graph, and from the graph write your y equals mx plus b equation. So you're going to start by writing y equals, and you need the slope and you need the y-intercept. Why don't you try that blue one first? Okay, so I have to be honest, I first noticed that the y-intercept, the b is 2. And what you need basically are 2 points in the crosshairs. So there's one of them right there, right? And then I'm looking for one. Oh, see, I've got one there. I mean, I've got a bunch of them, right? You really only need 2. So once you have 2 points in the crosshairs, you can find the slope, right? Rise would be 1. Run would be 2. 1 over 2. Now be careful. Make sure you put it into your equation the right way. Y equals slope 1/2 x plus b, which would be the 2. Okay, your turn to try the red one, and be real careful on this one. Okay, what's your y-intercept? Did you see the -6? So again, we can kind of put a point there, right? Now, where is there another one in the crosshairs? Right there, right? And even up there, we could keep going. But now, what is our slope? Well, our rise is not a rise, it's a fall. We're dropping 3 and running 1. -3 over 1 would be our slope. Oh, by the way, -3. And -6 is our y-intercept. And that's how easy it is to write the equation off of a graph. So we've done the basics of y equals mx plus b, which is the slope-intercept form of a line. We're going to learn 2 other ways to do that. There is a game out on the internet. It's called Save the Zogs. I'm going to go out. I mean, I have here the whole, address, but I'm going to go out. I think if you just did Save the Zogs and know that it's on Math Playground. So let me just go out here and find him. Here he is. So Save the Zogs. 4 frightened Zogs have left the safety of their planet and are floating around in space. The Duplicators, a band of space travelers with the ability to imitate others, have infiltrated the floating Zogs. This is making the rescue mission very difficult. Fortunately, the Zogs are very clever. They can position themselves along a straight line path. The Duplicators cannot. If the rescue team can determine the equation of the line, then the Zogs will be saved. The Duplicators will be left behind. Your mission, if you choose to accept it, is to rescue the Zogs, and you need to learn as much as possible about linear equations and the lines they create. What happens when the slope is 0, and so forth. So basically, you're going to start this game, and you find the Zogs. See them all lined up over here? So you need to write the equation of that line. Now notice it's a horizontal line, so the slope is what? 0. Remember I told you it's y equals a number, and in this case, y equals the 10. And it will, you put rescue, and it will draw through, and you just saved 4 Zogs. And you keep going, and it'll go next to vertical, and then finally it will tip it, and you can go and save a bunch of Zogs, basically. So your next step will be to practice this, and then if you have some extra time, feel free to go out and save some Zogs. Y equals mx plus b, guys. Have a great day.